presented by Ms. Yvette Chuca, Mr. Ruben Carizales, and Mr. Albert Isasi. Our session will be starting soon. The session will be recorded so that you may come back later to it if you need it, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now at this time, please mute your mics for the best sound experience. Otherwise, the feedback could interfere with information we'll be sharing with you today. Without further ado, here is Mr. Carizales.
Hello, everyone, and thank you again for joining us this Friday, taking a little bit of your time to review for your Math 1314 and your Math 1324 classes. As you see on the title, the session for today is to review for your first exam. So some of you may be having this exam this coming weekend or this coming week, so we want to get you ready for that. By showing you some of our most popular questions that you probably may see on your exams. Okay, so without further ado, let's go ahead and get started. And again, please, if you have any questions, please raise your hand, type them in the chat, and we'll gladly go ahead and answer those for you. Okay, so let's go ahead and start with this question. It says, find the distance and midpoint between the points 8, 4, and 8, -6. Now, we are going to use the distance formula to find the distance between these 2 points, and we will be using the midpoint formula to find the midpoint between these 2 points. And the first thing that I want to mention to you is that when we're using the formula, it doesn't matter which point you pick to be point 1 or point 2, as long as you follow the same order throughout the formula, okay? So in my case, I'm gonna consider this 8, 4 to be my point 1. So if this is my point 1, 8 would be considered my x1, 4 would be considered my y1. And the ordered pair 8, -6, I'm gonna consider that point 2. So 8 would be my x2 value, and -6 would be my y2 value. So the distance formula is given by this, the square root of x squared minus x1 squared plus y squared minus y1 squared. So all it is now is to substitute these values to the given variables. So we have 8 minus 8 squared plus -6 minus 4 squared. So let's go ahead and simplify. 8 minus 8 is 0, -6 minus 4 is 10. So 0 squared is 0, minus 10 squared is 100, and the square root of 100 is 10. Now, some of you may think, well, the square root of a number is a positive and negative, but keep in mind, we are finding distance, and there's no such thing as a negative distance, right? We only deal with positive. So we pick the positive value 10. So the distance between these 2 points is 10 units, okay? So let's go ahead and do the midpoint. The midpoint formula is you pick a point 1 and 2, and for the x value, you're gonna add its x components, the x1 plus x2 divided by 2, and then you get the y components, the y2 plus y1 and divided by 2. So let's go ahead and substitute our values. So we have 8 plus 8 divided by 2, -6 plus 4 divided by 2. We go ahead and simplify. 8 plus 8 is 16 divided by 2. -6 plus 4 is a -2 divided by 2. And we can simplify a little bit further. 16 divided by 2 is 8. And -2 divided by 2 is -1. So the midpoint between these 2 points is going to be 8 and -1. Okay? So again, any questions? If I'm going too fast, please slow me down. Please ask me questions. Okay? All right. So the next question that you might see on your upcoming exam is this: write the standard form of the equation of the circle with the given characteristics. And the characteristics that they're asking us is the center at -4, 2, and a radius of 2. So let's review what the standard form of a circle is. So the standard form of a circle is given by this equation: x minus h squared plus y minus k squared is equal to r squared, where h and k is the center point and r is our radius. So they are giving us the center, so they're giving us h as -4, k as a +2, and my radius is 2. So all we need to do is plug it into this formula and simplify. So we went ahead and put in the negative 4 for h, so we have x minus 4 squared plus the value for k is negative 2 or positive 2, which is a minus 2 squared, and our radius is 2, so we have 2 squared. So let's go ahead and simplify, and we end up with x plus 4 squared plus y minus 2 squared is equal to 2 squared is equal to 4. So this is our answer. This is the answer that the computer wants, and this is in standard form. This is in x minus h squared plus y minus k squared is equal to our radius. Okay? Questions? All right, let's go ahead and look at this example. Find the center and radius of the circle. Now we're kind of working backwards. They're giving us the equation, and we have to find these characteristics. So let's find the center of this circle. So I know that my center is given by the h and k values. So if I look here, my h here is 1. And since the sign didn't change, so this is telling me that my 1 is a positive value. But oh, if I look at here at the k, from compared to my standard form of the circle, it's supposed to be a negative, but here I have a positive. So what that meant is that my k initially was a negative. So because a negative with a negative is going to give me that positive. And then we work backwards. If I want to find the radius, so if this number was squared, opposite of squared is taking the square root. So if I take the square root of 25, that's going to give me the value 5 for the radius. So again, it's rewriting the equation to match the standard form of the circle. And here you could see just what I explained, that our values for our h value was a positive 1, the k value was a negative 2, and that when we take if we were wanting just the radius, they're not asking us for the radius, but if we wanted the radius again, we would take the square root of 25. But here, our center is 1, negative 2, okay? And then our center and our radius is 5. All right. Okay, I'm not sure on that comment. All right, so now let's sketch the graph. So hopefully by now we can look at this equation and we can determine and know that this is an equation of a circle. So let's start with what we know. We know the center. We know the center is at 1, negative 2, and we have a radius of 5. So we go to our rectangular coordinate system and we first plot our center. Our center is 1, our positive x1, and negative 2. We go down 2. So this is our center. So since our radius is 5, I can pick any point 5 units away from the center. Again, in the computer, to graph any graph, all you need is 2 points. So we have our first one, the center. And we can go ahead and pick any point that is 5 units from the center. You can pick any of these. Again, just select the circle option on your website and it will draw our circle, okay? And again, you can pick any of these 4 points to graph. Okay. All right, next question. Find any intercepts and test for symmetry with respect to both axis and the origin. So we have an equation here that hopefully by now we recognize is an equation of a line, and it's in a particular format. It's in slope-intercept form. So let's go ahead and solve for the x and y intercepts of this line. So to find the intercepts, let's go ahead and start with our x-intercept. So if we want our x-intercept, we're going to set y equal to 0 and solve for x. So let's go ahead and do that. Let's replace the y for 0, and this gives us 0 is equal to negative 4x plus 1. And let's go ahead and solve for x. So I'm going to subtract 1 on both sides, and it's going to give me negative 1 is equal to negative 4x. Now I want to isolate x, so I'm going to divide both sides by a negative 4. And when I do that, I have 1/4 is equal to x. So be careful on your homework and on an exam. If the problem says give the equation of the x-intercept, the answer would be this first one. 1/4 is equal to x. if the equation says give the ordered pair or the point of the x-intercept, you're going to label it as the x value 1/4, comma 0. Okay. Let's go ahead and find the y-intercept. To find the y-intercept, we set x equal to 0 and then solve for y. So let's go ahead and do that. Let's replace x with 0. It's going to give us y is equal to -4 times 0 plus 1. So a -4 times 0, that's 0, plus 1, that's 1. So y is equal to 1. So the equation of the y-intercept is y equals 1, and the point of the y-intercept is 0, 1. All right, let's go ahead and check for symmetry. So if we were to graph this, again, this is a line, and we know that does not have any symmetry, okay? All right, so let's go ahead and check to see that we don't have any symmetry, both in respect to the axis and the origin. So there's several rules that you have to follow. So let's go ahead and look at the x-axis symmetry rule. This says that if I change the sign of y and I still get the same answer, this will have x-axis symmetry. If I change the x value of the equation and I still get the same answer, then I have y-axis symmetry. And if I change both of the signs of the x and y and I still can get the same answer, then I have origin symmetry. So let me go ahead and do examples of what we mean by this. Okay. So in this particular one, we have this equation y is equal to -4x plus 1. If we would replace y with a -1, negative y and solve for y, look what we would get. So if we replace negative y with, y with negative y and solve for y, it would change our problem completely. We'd have to divide both sides by a -1 or multiply it by -1, whichever you feel more comfortable. Okay. And I would get this. I would get y is equal to 4x minus 1, which is not the original equation. I actually changed it. My original equation had a -4x. Now I end up with a positive 4x. My original had a positive 1. Now I have a -1. So since these two equations are not the same, therefore this has no x-axis symmetry. Let's go ahead and do the exact same thing for the y-axis symmetry. I'm going to replace the x value with a negative x, right? So go ahead and simplify and solve for y again. So I get y is equal to 4x plus 1. And if you see, my original one had a negative 4x, but with my change of sign, now I have a positive 4x. My plus 1 did stay the same, but again, they're not the exact same equation. So therefore, this has no y-axis symmetry. And let's do the last one. If we would test for the origin, if we change the sign for both the x and the y, and solve for y, we end up with negative y is equal to 4x plus 1. Again, it's not the exact same equation. Again, if I solve for y, we have y is equal to -4x minus 1. And our original one is -4x plus 1. We still have the -4x, but then instead of a positive 1 added, we have a subtraction of a -1. So again, these two are not the same. They're not the same from the original equation. Therefore, this equation has no origin symmetry, which we also saw from our graph. Okay? All right. So let's go ahead and determine whether the equations represented given are functions. All right. So let's look at the first one. Hopefully by now we see that this first one, y is equal to x plus 4, is the equation of a line. Okay. So the best way to determine if a function, if an equation represents a function is if we graph it and we perform our vertical line test. And what we're doing with the vertical line test is we're testing that every x value corresponds to only one y value. Okay, so if we graph this, again, this equation has a y-intercept at 4. It has a positive slope of 1. So this is the graph of my line. And again, if I would do an imaginary vertical line, my imaginary vertical line will only cross my graph once. So hence, yes, this first equation is a function. All right, let's look at this next one. Y is equal to x squared minus 2x plus 4. Okay, I know this is represented by a parabola, okay? And if I can graph any parabola, I can shift it since I know that the the leading coefficient here is positive, so I know that my graph is pointing upwards. And again, if I would perform my imaginary vertical line test, my imaginary vertical line would only cross graph only once. So hence, this equation is also a representation of the function. Let's graph the third one, the square root of x minus 4. So if I were to graph this, again, this graph from my parent function got shifted 4 units to the right, and it's just this curve. Again, if I were to perform my imaginary vertical line test, I would see that my imaginary vertical line will only cross my graph only once. So that means every x value corresponds to only one y value. So yes, this is a function. Uh-oh. Let's look at this one. This one represents a circle. So if I were to graph this, this is telling me that my center, since there's no h and k, my h and k are 0. So this is a circle at the origin with a radius of 2, because if I take the square root of 4, it's 2. So this is the graph. And again, if I were perform my imaginary vertical line test, I would see that my graph would cross at 2 places. So for instance, at 0, at the value x equals 0, I have 2 answers for y. I have a positive 2 and negative 2, and I cannot have that. Every single x value has to correspond to only one y value. So hence, this last one is not a representation of a function. Okay? Right, let's look at these. Determine whether the equation represents y as a function of x. So we have the first one here is a Q function, okay? I know that from our library of parent functions. This is the Q function that got shifted 1 unit down. And if I were to graph it, okay, it's this S-looking shape. And again, the graph got shifted 1 unit down. But if I perform my imaginary vertical line test, I would see that my graph would only cross once. So hence, this is a representation of a function. Let's look at this other one. Uh-oh, our y has now the square. So our parabola now has a major axis as the y-axis. So if to check, okay, we can solve for y and we can rewrite this a little bit. If you can't think of a rotation of the axis, we can see that when we take a value, okay, algebraically, if I pick a value for 0, um, I'm going to get 2 answers because this is a square root. Sometimes I'm going to get a positive, sometimes I'm going to get a negative. So this one is not a representation of a function because again, for a single x value, I have 2 different y values. Again, and if I were to graph it, again, it's this parabola on its side, okay? And as you can see, if I perform my imaginary vertical line test, it would cross my graph in 2 places. All right. So use the graph f of x of square root of x to write the equation for the following, for the function represented by each of the following graphs. So here, hopefully, I can see that this is a representation of a square root function, but there's several things that happen. I can see that if my parent was starting at 0, okay, um, it looks like this graph got shifted 2 units to the left. Also, it got shifted 8 units down. So how do we represent that? Represent that in an equation? So this is our parent function. It's like this. And I know that I had some transformations going on. I had a horizontal shift and I had a vertical shift. So here, I see that to demonstrate that I had a horizontal shift, that the graph got shifted 2 units to the left, I do something to my x variable, and it's apparent here, x plus 2. Because I am doing something physically to my x, I know that this graph is going to shift it 2 units to the left. And now why to the left if it's a positive 2? Remember, think of trying to solve for the x-intercept. If you want to solve for the x-intercept, you set this equation equal to 0, you have to take the square root of both sides and you have to move that 2 to the other side, which is going to make it into a negative 2. So hence, that's why this graph is shifting 2 units to the left. Now, how do I represent a vertical shift? I see that my graph got shifted 8 units down. For me to move 8 units down, I don't have to affect x anymore. the variable that I have to affect now is y, because y controls my movements up or down. So I have to get outside the radical, and this will be given by subtracting 8 outside the radical. So if this would go away, I would be left with the -8, right? Which affects my y value, making my graph shift 8 units down. So hopefully, if you recognize your parent functions, it's very easy to do these transformations because we understand how the graphs work. Okay. All right. How about this one? Uh-oh, it's a little bit trickier. So again, we know it. Our parent function is the square root of x, which looks like this. Okay. But we have some stuff going on. Okay. I see that it got shifted, has a horizontal shift again, but now it's to the right, and it's 2 units to the right. I also see that it got shifted down 5 units, but then it's upside down. It's backwards, right? So it had a reflection. So let's see how that interprets into our graph. Let's start with the reflection, okay? And it has a double reflection. So on this one, if I had a negative outside, it's going to flip my graph on, on its x-axis. So this is a reflection on the x-axis. But then it also has a reflection on the y-axis. And to do that, the negative now is inside the x because all the x values that I'm going to be looking at, or the input values that I'm going to be putting in, are all the negative values. So that's why the negative sign has to go inside the radical, because it's going to tell us that it's all the negative values inside. Now we can do our horizontal and vertical shift. Again, we move this graph 2 units to the right. So to represent that, instead of adding, I am going to subtract 2. And then I know that it's shifting 2 units, it's shifting 5 units down. So I have to get outside the radical, and it's going to be a -5 because it's going to control my y value. Okay. Any questions on these transformations or giving the equation based on the graph? Awesome. All right, let's continue. Um, Write equations of the lines through the given points, parallel and perpendicular to the given line. All right, so let's go ahead and do this. They're asking us to find the parallel and perpendicular lines to the given line, but in order for us to do that, we need a little bit more information. Now, the line that they're giving us, that they want us to do this information for, is given in general form, or some of us might call it standard form. But what I really need is, in order for me to find out if a line is parallel or perpendicular, I need to know its slope in order for me to give the appropriate lines. So the first thing that I need to do is convert this given equation into slope-intercept form so I can see what its slope and I can answer my questions. And the fact that they gave me a point, I know that I'll also be using, I can use my point slope formula to give the equation. So let's go ahead and do that. Let's first find our slope. So to do that, I am going to solve for y on this given equation. So when I do that, I have y is equal to 4x minus 3 halves. And just by looking at this, the value that I'm interested in is its slope. Okay, so again, I converted in slope-intercept form. The equation of slope-intercept form is y is equal to mx plus b, where m is my slope. So here, my slope is 4. So if I want to find a parallel equation to this, it has to have the same slope. Parallel lines have the same slope. So let's go ahead and find our parallel one, since we know that parallel lines have the same slope. So again, the best way to solve for the equation is, again, using my point slope formula. My point slope formula says that if I'm given a point and the slope, I can come up with the equation. Okay, so and it would be just plugging in. This 8,1 refers to the x1 y value, and my m, it refers to my slope. So let's go ahead and plug in. Okay, so let's substitute in our values and simplify. Okay, now what I want to do is, a key thing to remember, especially for the test. Okay, um, they don't tell you this, but they want the answer in slope-intercept form. Even though that I have an equation in point slope, they don't want the answer in point slope. They want the equation in slope-intercept form. So I'm going to distribute the 4, and then I'm going to solve for y. Okay, so when I distribute the 4, I got 4x minus 32, and then I'm going to subtract 1 on both sides, and this is going to give me y is equal to 4x, oops, did I go too fast? 4x minus 31, yes, double clicked it there. So the equation of the line that is parallel to this given line is y is equal to 4x minus 31. And as you can see, this new equation has the same slope, 4. All right, let's look at the perpendicular. I always like to say that if I want to find the perpendicular equation, I need the opposite slope. So what would be the perpendicular slope for this? So what I do is I convert this 4 into a fraction, and I take the reciprocal because it would be the opposite of the fraction, right? The reciprocal, and then change the sign, because if the given slope is positive, opposite to that slope would be negative. So again, the perpendicular slope that I want to use now is negative 1/4. They're giving me the 0.81 still. Again, I'm going to apply my point slope formula to this equation. So let's go ahead and plug in. Let's substitute the values into my point slope formula, which is y minus 1 is equal to minus 1/4 x minus 8. Let's go ahead and distribute the 1/4 so we can solve for y. Okay, so we're going to get y minus 1 is equal to minus 1/4 x plus 2. Then I'm going to subtract 1 on both sides. And when I do that, I'm sorry, I'm going to add, excuse me, add 1 on both sides. When I do that, it's going to give me y is equal to minus 1/4 x plus 3. So this is the answer that your test or computer is going to want to see for the perpendicular line. Any questions so far? Okay. Ms. Chuka or Mr. Sazi, do you guys want to jump in? Have any questions? Or want to add something?
Everything's fine, Ruben. Good job.
All right. Okay, then I'll move on. Okay. Um, let's look at this. Consider the following. F1 is equal to 7, F0 is equal to 8. They want us to write the linear function of the f that has the given function values. All right, so we have to understand one thing, okay? They're giving us functions. So when they say that f of 1 is equal to 7, this is telling me that when I plug in an x value of 1 into this function, my y answer or my output is 7. And they're also telling me that when my x value that I put in for this function 0, the y value that I get is 8. So I am given 2 points when they give me this representation. They're telling me that I have the point 1, 7. The 1 is for the x, um, and the 7 is for the y. And same for the other piece of information. The 0 is for the x, the 8 is for the y. So if I have 2 points, I have everything that I need in order to find the equation of the line. So the first thing that I would need to do is find the slope. So we like to use this example to practice finding the slope of a problem. So the equation of the slope is given by y2 minus y1 divided by x2 minus x1. And again, it doesn't matter which points you pick to be point 1 or point 2. The order doesn't matter as long as you label them correctly. So again, in my case, just because the way they're written, I'm going to choose 1, 7 to be my point 1, 0, 8 to be my point 2, and just substitute. So 8 is the y2, so 7 is the y1, 0 is the x2, 1 is the x1. So when I substitute that in, I get negative 1. So I have my slope of negative 1. So now all I need to do is find the y-intercept. So let's go ahead and plug it into our equation of the slope-intercept form. Y is equal to mx plus b. I have the slope that I just calculated. Y is equal to minus x. But now what I can do is I can substitute, okay, a value that I knew, okay? Since this one, 0, 8, I know that this is the y-intercept. This is when x is equal to 0, y is equal to 8, so I'm going to plug in that value. I know the b. So here, I have y is equal to negative x plus 8. So this one was easy. Now, I could have also used my point slope formula if it didn't give me the y-intercept, or if this point was, or you didn't see it, that this was a y-intercept. You would still get the same answer if you use the point slope formula, okay? So you want to be smart and try to look for these key features that will save you some time, especially if you have a timed exam, okay? All right, let's look at this example now. Find the function values if possible. We are given this function f of x is equal to 3x minus 8, and they want us to find the value of f of 1. Again, what this is saying is that I want to evaluate the function when I plug in x value of 1 into this function. So let's go ahead and do it. What this means that everywhere that I see x, I'm going to substitute that 1. So let's do this. 3 times 1 minus 8. So 3 times 1 is 3, and 3 minus 8 is a negative 5. So the function value, when I plug in x for 1, the y value is negative 5. Okay, let's do the second example. Again, this is telling me that everywhere I see x, I'm going to plug in now an expression, x plus 4. So let's go ahead and do that. We have 3 times x plus 4 minus 8. Let's go ahead and distribute the 3. And it's going to give me 3x plus 12 minus 8. Let's go ahead and simplify. And we have 3x plus 4. And this is our final answer. Okay. Our final answer for the first one was just a negative 5 when f of 1, when our x value is 1, our y value is negative 5. On this one, when our x value is x plus 4, our y value is 3x plus 4. Okay. All right. Let's do this one. Find the function value if possible. They're giving us this function g of t, which is equal to 5t squared minus 6t plus 4. And they want me to evaluate the function at the input 2. That means my x value is 2. So again, everywhere I see t now, it's not x, but it's t. Everywhere I see t, I'm going to plug in 2. So I'm going to substitute that t for 2 everywhere I see it on my equation. So we have 5 2 squared minus 6 times 2 plus 4. Let's go ahead and simplify. So 2 squared is 4. Negative 6 times 2 is a negative 12. So let's go ahead and simplify further. 5 times 4 is 20 minus 12 plus 4. And it's just simplifying, adding our like terms. So we have g of 2 is equal to 12. So when my input was 2, my x value 2, my y value or my output is 12. Okay. Again, please ask me any questions. If you feel that I'm going too fast, please let me know. Okay. All right. Let's do this next one. Find the function value if possible. G of t is equal to 5t squared minus 6t plus 4. Now, on this one, again, they want us to input an expression. It's not a single value, it's an expression, but we handle it the same way. Everywhere we see t, we want to replace it with this expression, t minus 2. So we have 5 times t minus 2 squared minus 6 times t minus 2 plus 4. And since it's crucial that I keep these parentheses because, again, I have an expression. So let's go ahead and simplify. This t minus 2 squared means that I have two of these guys, t minus 2 times t minus 2. I'm going to do FOIL, okay? So the t will multiply times the t will multiply times the minus 2, and then the negative 2 is going to multiply with the t, and the negative 2 will multiply with the negative 2, okay? So let's go ahead and do that first piece of information. So this is going to give me t squared minus 2t minus 2t plus 4. Combine our like terms, and we're going to get t squared minus 4t plus 4. And again, we still have the 5. Now let's look at the other one. We had to distribute the negative 6 to the t minus 2. So then we have negative 6 times t is a negative 6t. A negative 6 times a negative 2 is a positive 12. And again, we still have the 4. Okay. So the last thing we have to do before we combine all of our like terms is we have to distribute the 5 so we can get rid of the parentheses. So when we do that, we're going to end up with a 5t squared minus 20t plus 20. So now it's just combining all of our like terms. And when we do that, again, there is no other term that has a t squared, so the 5t squared stays by itself. We have a negative 20t and a negative 6t. So these are like terms, so we're going to add them together. So minus 20 minus 6 gives me a minus 26t. And then I have two constants. I have a plus 20 and I have a plus 4. So 24 um, is 24 on, and then I have the 12. Plus 12 is going to give me the 36. And this is my final answer. When my input or my x value was t minus 2, my output or my y value was 5t squared minus 26t plus 36. Okay. Any questions? All right. Um, let's look at this. Let's evaluate this combination function, right? What they want us to do is it says here, I want to subtract function g of t with function g of 2. So it's basically subtracting these two functions with these given inputs. So the first one's easy. G of t is basically just the equation that they're giving me. G of t is 5t squared minus 6t plus 4. But I'm going to have to do a little work. G of 2, again, what that means is everywhere I see t, I need to represent it by the 2, right? So um, that's the second one. Again, the first one, we went ahead and wrote it out that it's still the same equation. Nothing changed because it's what they're giving us to solve for. But for g of 2, the subtraction part, we need to replace the t with 2. And when we do that, okay, we're going to get g of 2 is equal to 12. So now we can do the subtraction. G of t is just 5t squared minus 6t plus 4 minus the 12 that we got of g of 2. Let's go ahead and simplify by combining our like terms. Our two like terms are just the two constants, the plus 4 and the minus 12, which is going to give us negative 8. So g of t minus g of 2, the answer is 5t squared minus 6t minus 8. Okay. Any questions? Again, want to remind everyone that make sure that you click on the links on the chat so you can get credit for attending our session today. Okay, so don't forget to go ahead and click on those to get credit. Also, I encourage you, please, at the end of our session, do the survey. All right, let's move on. Um, for the following, let's go ahead and perform these basic operations. Okay, so the first one is it wants us to add function f with function g, and they're giving us the two functions. F of x is x plus 2, g of x is x minus 2. So this is just performing basic operations. So let's do the first one, A. So this is the syntax that they gave me for basic function operations, but I like to rewrite them like this. I like to say that f plus g of x, what they're asking me to do is add function f with function g. And by me writing it like this, I just replace what these are and then simplify. So again, function f is just x plus 2, function g is x minus 2, and then I simplify it, combine my like terms. I have x plus x is going to give me 2x, and a plus 2 with a minus 2, that's 0. So the addition of function f with function g is just 2x. Okay. How about b? They're asking me to subtract function f with function g. So I like to rewrite it in this format, f of x minus g of x, and just substitute and replace. F of x is x plus 2. But because I have a subtraction, I want to put a parenthesis, make sure I distribute that symbol, right? That negative symbol. So we have minus the x minus 2. So to drop my parentheses, I'm going to distribute the negative. A negative with a positive x is going to give me a negative x. A negative with a negative 2 is going to give me a positive 2. Now I can combine my like terms. So x minus x cancels, giving me 0. And 2 plus 2 is going to be 4. Okay. All right, how about C? When we see two variables together, what this is implying is that they want us to multiply function f with function g. Again, I like to rewrite this in this format. They want me to multiply a function f of x with function g of x. And then I just replace. F of x is x plus 2. G of x is x minus 2. And I have to perform FOIL, right? To simplify, this x has to be multiplied with these two terms. This 2 has to be multiplied with these two terms. So we have x times x is x squared. X times a minus 2 is a minus 2x. 2 times x is a plus 2x. And a plus 2, the minus 2 is a negative 4. If we combine the like terms, the minus 2x plus 2x cancel, they go away, leaving me with just x squared minus 4. So again, I need to do a correction here. These two values went away, okay? Let's do the D, f divided by g. So I like to rewrite this just as f of x divided by g of x, okay? So just substitute. F of x is x plus 2. G of x is x minus 2. Since I can't simplify any further, this will be my answer. Please don't be tempted to cancel this x with this x or this 2 with this 2. Okay, this x plus 2, think of it as one body. I cannot break it apart unless I factor it out. So this is my final answer. X plus 2 over x minus 2. Okay, now, I don't know if I have it on here, but yes. So whenever they have us do these operations, when they want us to divide two functions together, they'll always want us to check our domain because this is one of our functions that has a restriction on the domain. We never want the denominator to ever become 0. So that's why they ask us if we can understand and interpret that. What is the domain of f of g? So if we look at this, if we can't see it right away, we need to say to ourselves, is there any x value that I'm going to put into my denominator that will give me a value of 0 on the bottom? So if you don't see it, solve it. Let's set x minus 2 equals to 0 and solve for x. And when I do that, I see that x is equal to 2. So that means if I were to put 2 in the bottom here, I'm going to get a 0. So, and you see that, right? 2 minus 2 is 0. So I cannot use 0. That's my restriction. Cannot apply 0 to this function. If not, I'm going to get an error or an undefined function. So the domain in interval notation, we write it like this. Again, we always read graphs from left to right. The domain for this function is from negative infinity to 2. And we use a parentheses. The parentheses indicates to us that we stop at 2, but we're not including 2. And then this symbol is the union symbol for interval notation. I like to call it and. So this is the left side of the values, and the right side would be continuing from 2 all the way up to positive infinity. So this is the domain for this given function. Okay. All right. Let's look at this. Evaluate the function for f of x is equal to x plus 3 and g of x is equal to x squared minus 2. So let's go ahead and do the product of these two functions. Okay, so they want us, I like to write it, f g of x. It means f of x times g of x. And let's just go ahead and replace. F of x is x plus 3. G of x is x squared minus 2. We go ahead and do FOIL. Okay, and when we do that and combine our like terms, we're going to get with x cubed plus 3x squared minus 2x minus 6. Again, the FOIL implies that this first term is multiplied to this first term here. This x term is multiplied to the negative 2. The 3 is multiplied to the x squared, and the 3 is multiplied to the negative 2. Okay? All right. Now let's do composite functions. So this open circle that's between these f and g, this means composite. This means f composed of g, g composed of f, g composed of g. So what this means that composite functions, instead of putting in a number or an expression, now we're putting in another function. So let's look at A, f composed of g. What they're really asking me to do is they want me to take function f, and to function f, I'm going to plug in function g. Okay, so the first variable that I have here is the f. That means my principal function f. So I rewrite it. I'll rewrite the function f as x minus 9, of x plus 4, and everywhere I see x, I'm going to plug in function g, which is x minus 9, yes? So when I do this, I have x minus 9 plus 4, then I just simplify it. I'm going to combine my like terms. Minus 9 plus 4 is going to give me a minus 5. So the composite function of f composed of g, or f dot g, some people call it dot, right? F dot g is equal to x minus 5. Let's look at b, g dot f. Now it's backwards. So my main function is g, so I rewrite it like this: g composed of f of x. That means that everywhere I see x for the function g, I'm going to plug in function f, okay? So here, okay, g is x minus 9. Everywhere I see x, I'm going to plug in x plus 4, which is function f. So my answer is x minus 5. Now, on this particular example, we got the same answer, but this doesn't happen all the time, okay? This one was just a lucky one that we have the same answer. So don't think that you always get the same answer. It just happened to be the same answer for this particular example, but this usually doesn't happen, okay? Now we get a lot of questions on this last one, g dot g, okay? This is no different. All they're asking us to do is that g composed of g. That means that for function g, everywhere I see an x value, I'm going to plug in the same function, g. So g is x minus 9, and everywhere I see x, I'm going to plug in x minus 9. So we have x minus 9 minus 9. Combine my like terms, x is equal to negative 18, okay? So these were examples of composite functions. Okay. All right. Um, let's move on a little bit more. Let's look at these two examples, practicing composite functions. Let's do f composed of g, for f is x squared and g is x minus 1. Again, we're going to follow the same format, rewrite it, and then substitute. I want to evaluate f for the value x. Everywhere I see x, I'm going to plug in that x minus 1. So I have x minus 1 squared. This means that I have an x minus 1 times x minus 1. Do FOIL, combine my like terms, and I'm going to get x squared minus 2x plus 1. G composed of f, right? So my main function is g, and everywhere I see an x value, I'm going to plug in function f of x. So we have g, and we're going to have x minus 1. Everywhere I see x, I'm going to plug in function f, which is x squared. So we have, when we simplify it, it's just x squared minus 1, okay? And then the last one, again, this is supposed to be a g dot g, okay? So when we do g dot g, again, we're just replacing g with its own function g, right? So we have g is x minus 1. Everywhere we see x, we're going to plug in the x minus 1. We combine our like terms, we're going to get x, this should be minus 2. Yes. All right. Questions? All right. Now, again, let's look at inverse functions. So we talked about, to find if a graph is a representation of a function, we do the imaginary vertical line test. We're testing that every x value has its own y value. So inverse, the name says it all, right? Inverse function is the opposite of a function. So if I want to find out if a graph has an inverse, instead of performing a vertical line test, opposite to a vertical line would be a horizontal line test, because the vertical line test is checking for every x value has its own y value. An inverse function states that every y value has to have its x value. So to do that, again, we perform our horizontal line test. So we would perform an imaginary horizontal line. We would see that our imaginary horizontal line will only cross our graph once. So hence, this representation, this is a graph of a line. This line has an inverse because my horizontal line crosses my graph only once. Okay, so um, so I already explained all this. So let's practice one where we have to determine or find the inverse function. So let's do this algebraically. So to determine whether the function has an inverse, let's find the inverse. So there's several steps to do this. So the first step for us to find the inverse is I'm going to convert this function into an equation. Okay? So hopefully you all see that this function is represented by a line, right? And I can see that from my power of my x. Since that my exponent is a 1 for my x, I know that this is a linear function, and I also recognize it's in a slope-intercept form, right? So let's go ahead and convert it into an equation. And I do that by replacing the f of x with the y, which what my function had replaced it before. So we have y is equal to 5x plus 4. So to find its inverse, the second step that I'm going to do is I'm going to interchange the x and y values. My x values are going to become y. My y values are going to become x. So let's go ahead and do that. So now I have x is equal to 5y plus 4. And to solve, I'm going to solve for y. So I'm going to subtract 4 on both sides. And then I'm going to divide by 5 on both sides. So I get y is equal to x over 5 minus 4 fifths. But to indicate that what I have solved for is an inverse, I have to replace the y with this symbol, okay? So this f to the negative 1, this means inverse. So again, on the computer puts this syntax on for us, but please don't forget to put it, if you're doing a paper exam, don't forget to change the y into the negative 1, because that's, you're telling me, or you're telling us, that you're indicating that what you solve for is for its inverse. Okay. um oh I I have a few minutes left, um and to continue practicing, if you guys don't have any questions, if we want to practice composites, we learned composites for many reasons. One, to do, but composites functions could also show us if what we solve for is an inverse. So if I were to do this, let me get my pen. If I were to, can't write, excuse me. There we go. If I were to do this, f composed of the inverse function, okay, of the x, and if my answer is x, then these two are inverses of each other. Okay, so let's practice. Let's see that the math that we did is going to give us an answer of x, and this is to practice a little bit more our composite functions. Okay, so let's do this. F composed of f. So our main function is f, so my function f of x is, again, I want to rewrite it like this. Okay, so again, I write f, which is 5x plus 4, and everywhere I see x, I'm going to plug in my inverse function, or what I found to be my inverse function. So I have 5 times 1/5 x, oops, minus 4/5, and then plus 4. Okay, there, made it. All right, let's go ahead and simplify. If I distribute this 5 into my equation, 5 divided by 5 is 1, so it's leaving me with x. 5 divided by 5 is 1, leaving me with minus 4. And then we have plus 4. And minus 4 plus 4 is 0, so our final answer is x. So we did our work right, that this is the composite of this, and we did that by verifying using composite functions. All right, guys, so again, if you have any questions, please feel free to ask us. If you want to review some more of the material that we covered, or some of the materials that we did not cover in this session, please stick around. We have awesome tutors that are willing to work with you some more, help you out, any questions you may have. Again, Mr. Sasi, Ms. Chuka, do you have anything to add? You'd like to add anything else that might be of importance to the students?
I just wanted to say, I wish you all the best for your exams. I think most of you are going to be testing this week or next week, and have a great weekend.
So yes, thank you all for joining us. Again, have a happy weekend. Also have a happy Valentine's Day coming up Monday. Maybe that's when your test is. You know, your teacher's gonna give you a Valentine's card, right, for your exam. But thank you again for joining us. Have a great weekend.
Thank you, everybody. Please join us next Friday, February the 18th at 3 o'clock for our next Happy Math Hour session. For Math 1314, the topic will be standard form of quadratic equations and graphing. And for Math 1324, it'll be writing exponential equations into logarithmic form. Please know that online tutoring is open now and available 7 days a week from 9 a.m. to 11 p.m., Monday through Sunday. And face-to-face tutoring is available Monday through Friday, 8 to 5, 8 in the morning to 5 in the afternoon. Thank you so much, Mr. Carizales, Ms. Chuka, Mr. Isasi, for presenting today. Thank you, audience, for coming and being a wonderful audience. And we hope to see you again soon. Bye, everybody.